Andy, you can start at any time.
Thank you. Hello, my name is Eddie Ambler. I'm an Exadata database service and database cloud service and multi-cloud PM here at Oracle. Today, we will be having a tech talk conversation about Exadata Hybrid Columnar Compression. Joining me is my colleague, Leo Alvarado, who will also help us.
Yep. Hello, everyone. My name is Leo Alvarado.
Hi. Thank you, Leo, for joining us. Today, we will be focusing specifically on Exadata Hybrid Columnar Compression and how we can increase performance and lower the cost of your Exadata by leveraging HCC. So let's get started. Looking at the agenda, we will go over the topic introduction. We'll have a brief conversation of what the Oracle Converged Database actually is. We'll go over what the Oracle Cloud Database offerings are, and then we'll delve into what is HCC, right? What are the typical pain points that we can benefit from by applying the compression? Then we will pivot to talk about the Compression Advisor, which is a tool that we can use to understand our storage savings. Then we will come towards the end and talk about the results by going through a discussion of the different compression levels that we entertain. We will then align the compression strategy with workload type so that you can clearly understand what type of compression best meets your storage savings and your performance objectives. And we'll open up the floor for Q&A. In the meantime, if you have questions, please enter your questions into the chat, and towards the end of the session, we will make sure that we go through those and answer any questions that are there. So let's talk about the topic, right? So how to leverage Exadata Hybrid Columnar Compression. You'll hear me say HCC to create your data models that are highly performant, space efficient, and that actually meet your data lifecycle needs. You know, HCC is often used to help the customers to reduce their storage utilization, to increase performance. And that's something you don't typically think of when you think of compression as performance. It's usually a conversation around storage. But you'll see here how on the cloud database platforms with Exadata, that applying HCC will not only save you storage, but improve your analytics queries. It'll also help you to reduce your CPU utilization on the compute servers, address things like reducing backup times, reducing the amount of storage that your backup actually requires, and ultimately, save on your database software. So as we go through the slides, just kind of look out for the learning points that you see here. We'll call them out as we go. So as much as we want to focus here to make sure that you understand the value of HCC, we're going to use this session as a teaser for the next one, which is, not only are we going to show you in the series how to apply HCC to get the best value out of the system, we're going to also show you in the upcoming series how to automate that, right? Yeah, in the cloud, it's all about automation. How do I automate the delivery of data tiering compression utilizing Exadata HCC, the heat map, and the ADO policies. So, do you know what's included in your Oracle Enterprise Edition database software? As you can see on the slide here, Oracle is much more than a relational database. The Oracle database is a converged database that supports many data models that can be accessed from a single SQL command. Having these data models integrated in a single data store is a huge value point over other database platforms, which they would need to offer you many different point solution databases that you would need to also then deploy. You'd have to manage them. You'd have to integrate them. So there's a lot of work. Oracle database already has all these data models pre-integrated. It's one data store to manage, secure. And so why you spend the time redoing what has been in place, as you can see from the timeline over the last 25 plus years. The Oracle database software can be run on-premise on hardware, all the way through any of the cloud platforms, giving you extreme portability to be able to build things like hybrid cloud and port your application on-premise, in the cloud, not just on Oracle's cloud, but on any cloud. The Oracle binaries are the Oracle binaries. The Oracle Database Cloud subscriptions, they range across the spectrum of service editions and automation levels that best meet your demands. You can choose from single instance cloud databases to 2-node racks on our enterprise and standard edition database service, or from Exadata database service in the public cloud or on Cloud at Customer when you need more scale or performance. And for those who want a fully managed experience, you can also choose from one of the autonomous database offerings. So now let's start to get into the meat of why we're here. How Oracle stores data. It's important to kind of get a good understanding of this viewpoint so that you can understand how the hybrid columnar compression actually delivers on the performance and savings there. So for example, we take a SQL statement that is going to create a table, in this case called guest table. The first thing that happens is data blocks are assigned where your actual row data will be stored. The extents are allocated that group a contiguous set of data blocks that then get mapped to segments. And your segments are actually the logical structures that you're used to seeing. So for this example, we would end up with a data segment, which would hold our data, and an index segment, which would hold the index data for us. So, on this screen here, we get a detailed view of how Oracle stores the row data in database block. What I want you to note here is that each row has a row header section with details such as the number of columns and the column data section that includes things like the column length and column value. Now let's move to the next slide to see how using advanced compression impacts the storage and data blocks. So we will get to HCC, but I kind of wanted to build up on how Oracle does compression with row levels so that when we get to hybrid columnar, you can understand the difference. So when it comes to compression in the database, Oracle provides either basic compression for free and advanced compression, which is a licensed feature, right? Advanced compression happens at the block level in batches. This is what allows the system to be able to keep up with frequent data changes that OLTP environments provide. Individual inserts and updates don't actually cause the recompression, right? This allows our OLTP performance to continue. As you can see in the diagram, the blocks begin to fill with data, and periodically the blocks are compressed to create more space. Along with providing you storage savings though, another impact of applying compression is that the read performance also normally increases due to the need to perform fewer IOs and the improved memory utilization efficiency. What do I mean by memory efficiency? The memory efficiency is improved since more rows are able to be stored within each block in memory when compression is applied. Wow, we made it. What is hybrid columnar compression? The introduction of the Exadata database machine for the Oracle database included an additional compression technique known as hybrid columnar compression. Hybrid columnar compression, as we said, is known as HCC, is an innovative method of organizing data within a database table that uses a combination of both row and columnar methods for storing the data. The hybrid approach achieves the compression benefits of columnar storage while avoiding the performance shortfalls of a pure columnar format. So HCC on Exadata enables the highest level of data compression possible with the Oracle database, as we will see in our demo. Data compression provides substantial cost savings and performance improvements due to reduced IO, especially for analytic workloads. So when it comes to the storage savings, this is going to be data dependent, and it often ranges from 5x to 20x. The average storage savings in the industry is around 10x. There are two modes of hybrid columnar compression. You'll see warehouse compression mode, which is also known as query mode. And this is suitable for read-intensive workloads and provides large storage savings and enhanced analytics performance. The second method is archive compression mode, which provides the highest degree of compression, but it actually doesn't offer quite as fast of read performance. On OLTP systems, hybrid columnar compression can be used to compress older, less active data, while newer, more active and update-intensive data can use advanced compression as we discussed earlier. Through the use of partitions though, tables can be designed to benefit from the use of multiple compression techniques. For data analytics, using HCC accelerates reporting and analytics queries while maintaining excellent performance for OLTP style single row lookups. The Exadata Smart Flash Cache implements a unique algorithm that actually accelerates reporting and analytics queries. We call this Exadata Columnar Flash Cache. So what happens there is the columnar flash caching has a dual format architecture. It automatically transforms frequently scanned hybrid columnar compressed data into pure columnar. And what this does is then the smart scans are just on those columns, reducing the flash IOs. And this then saves a ton of storage CPU consumption. We'll provide more detailed guidance on the use of HCC modes in the upcoming slides. This should be one of the last pieces of the technical background before we get to the demo. It says, what is a compression unit, right? A compression unit is a logical construct that stores a set of hybrid columnar compressed rows, right? When data is loaded, the column values for a set of rows are grouped together and compressed. After the column data for a set of rows is compressed, it is stored in a compression unit as shown on the screen. In an ETL workflow, you could see that an order by statement before loading the data would return extreme dividends when HCC is applied, as deeper compression ratios would be attained, providing greater storage savings and performance improvements. The initial cost of the order by statement could be time well spent. Applying HCC should be tested in your development space, promoted to QA, and then deployed in your production environment. While HCC is optimized for scan level access, Oracle is still able to provide efficient row level access. With HCC, entire rows are typically retrieved within a single IO because the row data, as you can see, is self-contained within a compression unit. With pure columnar formats, the problem is that at least one IO per column for row level access is required. So let's get started with the HCC. How can HCC help us address the pain that customers have? So you can see that our customers in the field, they're actually experiencing things like, my data is growing and it's exhausting the available storage. I need to avoid the costs of storage expansion, right? My query performance is slowing down as my data volumes grow. My backup storage requirements are continuing to grow as my data grows. The time it takes to do the backups are exceeding the SLAs, and I need to lower my backup times. The business is saying, hey, we want to keep more data on site for reporting. Or you're getting a feedback that says, we want to remove the need to send data offsite for archive storage. These are all things that HCC can help.
Yeah, we can all feel the pain with just looking at this list, Eddie. And just to share with my previous implementation in HCC, in which I do have a customer that has a business directive to comply with data retention. And when you talk about data retention, it means huge data for them, and that they have a challenge on supporting the data growth. At the same time, they need to avoid cost. So this customer implemented not just HCC, but it's a combination of HCC and partitioning. So they use HCC to store their data, and they use the partitioning piece, making sure the archive data doesn't affect the performance. So it's HCC can go hand in hand with partitioning as well to address these challenges in terms of data archiving and performance.
Wow, thanks, Leo, for sharing that. And we'll see that pattern continue as we continue our discussions, how multiple database features and Exadata features work together to give you that holistic performance at the best possible price point as well. Well, let's get started with HCC. You know, seeing is believing, right? So Leo, why don't you walk us through how we actually work through the demo here?
Okay, so let's talk about the environment. So first, we created the table, which is a 640 million rows uncompressed, 50 gigs in size, and that we spin up an Exadata database service on dedicated infrastructure, or you can call it the Exadata on Oracle Public Cloud. So we spin up the flexible infrastructure, comes with the 2 database servers and 3 storage servers, and then we just enabled 4 OCPUs. And then we have created a 19C database running on a grid infrastructure 19C, a fully encrypted database. So that's our testing environment for this demo.
Awesome.
And then we then create the sample table just to prepare the HCC discussion. So we have created 50 gigs. So just to show you that this is uncompressed table. And then we try to create the compressed versions of the table. So to be able to compare the compression impact, so we have created 5 tables for different compression methods. So here's the sample syntax that we have used. So we loaded our HCC compressed tables using a direct path load. And in the table, it shows that I wanted you to focus on the compression level applied, as well as the number of rows in the table and the size of the table. So we can see here the results of applying those different compression methods onto your table. So Eddie, do you want to add on this one in terms of the results?
Yeah, I think, you know, what I wanted to just kind of point out here on the table is that, you know, you'll note that as we actually increase the compression level, and see we went from advanced OLTP compression to HCC query low, to HCC query high, to archive low, archive high, that as we increase that compression level, the size of our object actually continued to shrink. You know, that's an important thing. So, you know, in the upcoming slides, we'll talk about the trade-offs to performance as we, you know, enable these sizes.
So before you proceed, I mean, while we're doing this testing, so I just have some few questions. Like, if you're enabling the compression for an existing table, like, would this affect the existing data inside?
Well, it depends. You are able to actually enable compression for future data and leave the existing data alone, right? Or you can actually compress existing data and data moving forward. So you get a choice. You know, what you'll find as we get into it is that the compression algorithms are able to be applied at a whole table or a partition or a subpartition. So you can be very selective as to where the compression is applied. And another great feature is that, you know, you can actually even apply compression to the objects online, you know, making sure that you maintain access to the data while the compression activity is occurring.
Then can I still compress the data that is already loaded?
Yeah, again, you can absolutely do that. If data exists in a table, you can actually apply the compression to it. And again, you can be very particular. Maybe you only want to compress a certain part of the data, right? Maybe it's a partition table and there's certain partitions you want to compress. So you can target very specific partitions or subpartitions. So very, very flexible at your ability to target just what you want to partition, compress.
Yep.
All right, cool. Well, thanks for those questions, Leo. So let's take a look at the compression advisor, right? The Oracle database provides you with a compression advisor package that's called DBMS compression that allows you to estimate potential storage savings. The compression advisor allows you to get a storage savings estimate for various compression types. Since the compression algorithm is in the database, you can even project Exadata HCC compression savings from a non-Exadata system. Now, the value to your organization of the compression results achieved will depend on whether you are prioritizing for storage space savings or performance. On the upcoming slide, we will review the impact of choosing different compression levels on our data set so that we can select the compression level that best meets the organization's demands.
I think, Eddie, we got some questions like how long did it take to insert all the compressed modes?
Awesome. Well, I tell you what, I'm going to actually give you a great viewpoint of that coming up. But before I move on, I wanted to kind of walk you through the syntax on the screen. So you can see that I got 4 spots on the syntax highlighted in yellow. And those are really the only things as you go through the advisor you need to change. You see that the DBMS compression package is being used to call the get compression ratio. And I'm passing into it the scratch table space that I want to use, the schema owner, and in our case, the name of the table, my table. The next one down it says compression query low. I'm actually defining the compression level that I want the advisor to estimate for. This could have been OLTP, it could have been query high, could have been archive low, archive high. So any of the valid compression levels that are available, I can actually put that here. And then it will go off and run. And the output at the end of the block will come back and say, for the compression type that you asked, in this case, compression query low, the compression ratio that's estimated is 6.
So is the compression ratio the same for all tables?
Oh man, that is a great question. So the compression ratio will vary widely. It really depends on your data set, how the data was loaded, was it order data that we're working on, or is it truly random data? So what this is giving you is the ability to get your answer. This is why it's very important to run the compression advisor. We can give you ranges of what you can expect out of different query types, compression types, but the right way to understand it is to run the advisor so that you, on your largest set of tables, so that you can get a really good feel for the value that you will get.
Then is the compression retained for backups? Like,
oh, absolutely. And this is a great point. When you actually use HCC in the database, the data is compressed and retained in its compressed state in the database, so that every time you back it up, it's also retained in its compressed state in the backup. Now, we've all used Armin, right, and the compression flag there, right? Well, the problem with that approach is every time you spin up a backup job and you run, you have to then compress the backup. Well, that takes a lot of CPU cycles and time. Now, with HCC compression, you compress it once, it's stored in the data once, and every time you back up, you never have to hit the compression cost again. So this is also another feature that will also help to speed up the backup time, not just in terms of storage, but also it also reduce the CPU requirement because you won't be spending cycles recompressing data again. So great question. All right, let's take a look at the compression results. All right, so here in this table, you can see that we have outlined the tables that we used, right? The table that had no compression, and then our 5 flavors of tables that had the various degrees of compression. You'll see that the size, which we looked at earlier, continues to decrease from the 50 gigs down to to 400 megabytes with compressed archive high. But then as you look at the column on the far right, you'll see the trade-off. So as we loaded the 640 million rows into the tables that were enabled with the different compression levels, the trade-off was that we actually experienced slightly higher load times due to the overhead of the compressions that were being applied. So you could see that, if I want the deepest compression level, I would go with compression archive high. And, if I wanted a hybrid of compression depth and performance, then I could probably pick between HCC query low and HCC query high. And if HCC query high is the default setting at the moment. So note that as we increase the compression level, that the data load performance time is absolutely impacted. Now, if you're going to be storing things for long-term retention, then you really don't, you really want the most amount of compression, right? And you're less likely to be concerned about the additional time it takes to load the data into its compressed state.
Yep. So I think this answers the question on our Q&A for the load time for the different compressed modes. So this is great results. Now the question is, how do we determine these compression levels how do we map it to actual workloads?
Well, I am glad you asked that question. We actually have that very topic coming up next. So let's talk about mapping compression types to workloads, right? So, you can have data that's hot and that has frequent DML. For that kind of data, what we recommend is advanced compression, right? But then, as your data, if you have data that is considered warm, meaning it has frequent selects but low updates and deletes, this is where you can use your HCC query low, query high. If your data is considered cool, we would use HCC archive low. This is for data that has low select, low update delete as its profile. And if the data is considered cold, this is where we would use HCC archive high as the compression level. And this is targeted for data sets that, they're infrequently accessed and they have rare updates and deletes. Now, if your table is not partitioned, what you have to do is take a look at the data characteristic and pick the compression level that meets the more aligns with your level of activity, right? Your selects, updates, and deletes. And then you'll also balance that, as we looked at, with the sensitivity of the data loads. But if your table is partitioned, this is where you get the most flexibility, because literally you can apply each of these compression types to your partitions based on how hot the data is. So as you go down the partitions, usually the activity in the partitions cools down, as we discussed, and you can then actually continue to increase the compression level as you go down the age of your partitions. So this is a great way to be able to get the most compression out of your database at the partition level, saving you the most storage and giving you the best performance that you get. So Leo, are there any other questions in the chat at this point? Well, you know what, let me back up. So, I've got a few compression tips that I want to talk to you about before we go to Q&A. So, although HCC can be used on tables with inserts and deletes, as we discussed, it's best used in data that's being queried and not intensively being updated and deleted, right? The general recommendation is to compress the application related tables in the databases with an appropriate level of compression. We don't recommend that you compress tables that are used as queues. What do I mean by that? Tables where you're loading the data, then you're deleting most of it, reloading the data, and going through that cycle, right? Advanced row compression is better suited to handle volatile data where you have many DML operations and where you have lobs and clobs, right? It's a great tool for doing deduplications for lobs. And just like HCC brings tremendous value, advanced row compression for applications that have lots of lobs and clobs is a great way to actually truly shrink your database size. The other one is applying partitioning, right? If your tables don't have partitioning and you really want the flexibility to apply the right compression level across your object, having partitioning really gives you that flexibility to set the right compression level. And with HCC, there's no need to roll off partitions. You can compress them, as we saw with archive high mode, and get a very deep partition. This helps to extend the use of your data for things like reporting, analytics, legal retention holds, and things like that, without having to spend more money to ship the data to another system or offsite. It keeps the data closer nearline so that you can get more value out of it. We talked about the things in the notes along the conversation, but I'll mention them. HCC is not supported for long data types. It's used for relational data and not unstructured data. For the unstructured data, we would probably want things more like the advanced compression. Clobs and blobs are best stored in secure files, right? And compressed using advanced compression. And finally, HCC is only available on Exadata storage and ZFS storage appliances. But remember, we can actually estimate HCC storage compression savings from any system, right? That way you're not locked in at all. You can take your HCC advisor, figure out what it is if you go to Exadata. And once you're on Exadata and you're using HCC, if you ever needed to go port that data somewhere else, not a problem. You can always change the compression to what is supported on that platform. So at this point, Leo, are there any other questions in the chat that we need to address?
Yeah. So there's one question. What happens when we have updates to cool data, to the cool data?
Okay. So what can happen with HCC, right, is that it can force that partition to become uncompressed so that it can put the data in. So that's a negative item there. So you don't want to continue to have to update or recompress the partitions. Now, one of the things I'll say is as we move forward and we introduce the heat map and the ADO policy, which allows us to move the compression down to the block level, then that becomes less of an issue, because now to manage that update, right, all I have to do is uncompress just that 8K block and not the entire partitions, which is why in our strategy, as we talked about finding the right compression type to apply, right? One of the characteristics was to understand the update delete frequency that was experienced.
Okay. Then another question is, if we are already using advanced compression or ACO, what can we expect from switching to HCC?
Wow. To answer that, let me actually take you back to the results table that we had. So you could see that advanced compression gave us a compression ratio of about 2x. When we moved to query low, we would go instantly, which is the lowest HCC compression level. You can expect somewhere 5 to 6x compression ratio. So you would be saving storage by almost another additional factor of 3x, right? But then not only would you be saving storage, but because the data is maintained compressed in the storage, in the flash cache, and in the memory, you'll also be increasing performance for the entire system, as you'll be able to store more rows within each one of those tiers of storage. So yeah, so moving from advanced compression to HCC for partitions and tables that have the right characteristics can actually further increase your overall performance. Any other questions out there?
I guess those are all the questions that we have.
All right. Well, we'll pause for a minute and give folks an opportunity to, add additional questions in the chat so that we can address those. And Leo, if there are no other questions, what would be good is if maybe we could share with the audience, where they can find additional information, right? It's a lot of information maybe to absorb right now, but I know that we've got some great resources that could help them.
Okay. So where can I find available solutions for Exadata database service? So first is that we have a public Slack workspace. It's called Exadata-database-service. So when you join the Slack workspace, we have prepared there those get started guides. So these are get started guides both on documentations as well as how-to videos if you wanted to launch and start your Exadata database service for both dedicated infrastructure and on cloud at customer. That's where we also be featuring some technical blogs about Exadata database service and also posting the upcoming Tech Talk series. And then other collaterals, we suggest you to visit database.oracle.com and exadata.oracle.com. So for the public Slack workspace, so I'll pause for a moment. So the workspace URL is here, or you can just go to the bit.ly link or scan the QR code. It's called Exadata-database service. So the steps for you to join, you can just scan the join link, and then it will ask you to log in your email account for your Slack. You need to configure and set up your 2FA, and that's it. Welcome to our workspace. So we would like to invite every one of you to join our public Slack workspace so you can post some questions there. We can do discussions. We can share those new demos, technical how-tos that we have. We'll be updating the Slack channel for upcoming Tech Talk series after this topic.
Thanks for that, Leo. Well, this brings us this session of Tech Talk with Leo and Eddie to an end. Until our next session, stay safe and be prosperous. I'm
Thanks,
Eddie,
everyone.
and he's Leo. Bye for now.